Good morning, everyone. My name is Jun Xiaohan, a PhD candidate from Zhejiang University. The title of my presentation paper is What do programmers discuss about deep learning frameworks? This is the outline of the presentation. Now we come to the introduction part. As we all know, deep learning has developed rapidly and gained tremendous traction in the past few years, and its technology has been widely used in various domains. Deep learning frameworks are proposed to help developers and researchers easily leverage deep learning technologies, and they have attracted a great number of discussions on many popular platforms. To understand and compare the insights of different deep learning frameworks on different platforms, we mine the topic of interest and topic trends from Stack Overflow and GitHub platforms. We chose TensorFlow, PyTorch, and Theano to perform this study due to that the three deep learning frameworks are all typical in deep learning domain. In the research setting part, I will introduce the research questions, research data, and research methodology. We have three research questions. AQ1. What issues do practitioners discuss about deep learning frameworks? AQ2. What are the differences in the discussions across deep learning frameworks? And AQ3. What are the differences in the discussions between Stack Overflow and GitHub? We mined deep learning discussions from Stack Overflow and GitHub, and this is our research data. Needless to say, we divide our dataset into 6 groups, such as TensorFlow on Stack Overflow, PyTorch on GitHub. This slide illustrates an overview of our research methodology, including data pre-processing in step 1, determine the workflow and basic stages of the deep learning domain in step 2, deriving LD topics in step 3, aggregating the LD topics into topic categories in step 4, and determine the dominant topic and topic trends over time in step 5. This is the determined workflow stages in step 2. After the several steps, we have topics with different granularity, that is, workflow stages for coarse granularity, topic categories for medium granularity, and LD topics for fine granularity. Then, we introduce the results in this part. Firstly, we introduce our findings for AQ1. We derive 75 LD topics for the 6 data groups. This is the percentage of posts recorded in the workflow stages and aggregated topic categories for the 6 data groups. The multiplication sign number indicates the number of LD topics matched with a particular topic category. We can find that the most frequent discussed workflow stages are model training and preliminary preparation. In AQ2, we discussed the commonality and difference of discussion topics across different deep learning frameworks. We find that for Stack Overflow platform, TensorFlow and PyTorch always keep the same pattern as for the topic distribution at the workflow level, while Theano is quite different. TensorFlow and PyTorch are all mainly concentrated on preliminary preparation, data preparation, model setup, and model training stages, while Theano mainly fall into the model training stage. This is the comparison of the topic trend at the topic category level on GitHub platform across different deep learning frameworks. The performance topic category is only distributed at TensorFlow and Theano. Its impact was relatively small during 2016 to 2017 for TensorFlow, while presented a sharp increase after January 2017. In AQ3, we discussed the commonality and difference of discussion topics on different platforms. We derived the trend lines of the topics at different workflow stages on different platforms, and observed that model training on the 2 platforms showed the highest impact compared to the other workflow stages. Model setup experienced a sharp increase since 2016 on Stack Overflow, while the impact of it on GitHub is slight. We find that the most frequent discussed workflow stages are model training and preliminary preparation for all data groups. For researchers, this will be an ideal area for further research. Besides, they can also try to summarize and categorize the errors encountered in their development process to help provide guidance for developers and users. For practitioners, we can persuade them to consider complementing the documentation system, augmenting the tutors, improving the framework, accessibility, and so on. In the future, we plan to incorporate more deep learning frameworks to make the analysis more common and generalized. That's all. Thank you.